So we will be working with 3 tools tonight. Git, which is the original tool. GitHub, which is one of the web services, which also offers you a software package for your computer. And GitLab, which is a different server. Okay, so tonight we will be understanding what commits are, what branches, and tags, what are those. You guys will be starting your own repository or forks. You will be committing, branching out, merging, tagging, etc. And you will be revisiting your project's history. And you will be engaging in basic collaboration. So why would you guys need Git? This is the reason. This is your documents folder, right? You have a dissertation folder, you have a copy of your dissertation because you needed to make some changes, and then you have the source code of your model, but then you needed to do some changes to the source code of your model, so you made a copy, and then you made a backup, but you don't even remember what the backup was about, so later you made a backup of the dissertation and a backup of the source code, and then you needed to make changes to the source code, so you created a folder named new version, but you don't even remember what it was about. Then you get angry at yourself, and then you start using numbers or dates, so you make a 2.0 source code, a 2.1 source code, a source code corrected, the slides of your presentation, your music, your paper, etc., etc. You have drafts and drafts and drafts for days. So once you are in a scientific environment, this multiplies, and this happens to everyone. So we want to have a tool that helps us organize this mess. So this is Git. Git is a version control system created by Linus Torvalds in 2005. And he did it with the purpose of managing the development of his Linux kernel. Now, this is an open source tool that is available for everyone, and it has been in use for most Linux and web services for the development of most source code that you guys use every day. And it has been available for you guys to organize your projects, your research, your dissertation, your designs. So, we will be exploring the concepts that Git introduces, and later we will be starting with a hands-on approach of how will it work for our own projects. So the first concept that Git introduces are commits. You'll have to bear with my Spanish accent, sorry. Sometimes I said hit. That's just how it sounds in Spanish. And I don't know how to pronounce commits. Can somebody help me? Commits, okay? Okay, so when you are working with the concept of commit, you can imagine the history of your project. So you started in commit A here, and you started to introduce changes in your project. Little changes to your source code, and these changes have been addressing particular problems with your model or particular features that you want to add. So what these commits represent are logical changes, not just like from one line to the other, but packs of changes that represent particular features that you know logically how they work. Now, this history that we have represented here by this arrow starts in the past, and we call it the base of this history, and the head would be representing the present. And we will be using these concepts of base and head throughout the tutorial. What are commits and this project history useful for? In the first place, it allows us to compare file versions. You can compare this version with any other version, for example, how your project has changed from the beginning to its present state. Most importantly, you will be able to revert the files to a previous state. For example, you want to examine the causes for problems with your model or your dissertation, and you want to examine how it was some time ago. You can check out those files and open them with your with the same software tools that you were using before. You will also be able to identify the author of each change. Well, initially the author of every change is only yourself, but you will be able to collaborate. So it will be important to identify the author of each of these commits, because individual authors can create each of these commits. You will be able to identify the change that introduced the problem. So being able to look at your changes objectively and logically will enable you to correct those problems in a better way. So what's in a Git commit? There's a hash or an identifier. It is, when we are getting started with Git, we just use a letter. And that's what you will find in the documentation, just a letter to represent, just as we had here in this history A, B, C, D. But in Git, commits are identified by hashes. It's just hexadecimal numbers. One example is here. A Git commit also contains the author, the date, and the description of this change. And you guys are taking charge of writing this description in a meaningful way. Yes, Mike. Now, the most important part of the commit are the changes themselves. The changes are expressed in two possible ways. First, compressed differences. You guys know that most of your source files, such as C++, Python, NetLogo, etc., they are plain text files. And Git saves your changes in the most efficient way possible. So it has tools to calculate only the differences of files from one version to the next. For example, when you guys typically look at one of these commits, and you look at these red lines with this minus sign, they represent lines that have been removed from your source code. And these plus signs, this green color, represent lines that you have introduced into your source code. Other kinds of files, such as Word documents, images, higher level designs, will be saved in their complete form, and they will be compressed as whenever it's possible. The next concept that we learn when using Git are branches. They represent the capacity that we have to create different histories in our development. For example, what we call here the master branch contains the most stable versions of our source code. But whenever we are developing new features or fixing problems or experimenting with our source code, it is always wise to create new branches that allows us to diverge. For example, this branch here, the branch named develop, it contains these two commits, G and H, but it doesn't contain these commits, C, D, and E, and F. So it will allow us to diverge, to make changes on top of this version of the source code. Make changes, test the source code, and in the future we will be able to merge those changes to make a combination of those changes into the master branch. Now, the recommended workflow is to have a master branch with the most stable version of your model, develop branch with features that are being tested, that need more testing, and topic branches which will contain your most recent, your newest features or your fixes or your experiments, and these are the branches on which we will be working the most. Now, branching has also a very important function, which is allowing you guys to collaborate in an independent form. If everyone were to make their commits on only this master branch, you guys would get a big mess here with changes introduced by everyone. This master branch is shared among the people who are collaborating in your project, and usually the develop branch is also shared among everyone. Topic branches usually are private. You create them yourselves. You create them yourself and you make your changes, you experiment with your new features, and after that you will be sharing those changes when you are perfectly sure that your changes, your features are stable, do not produce problems to your model. Then you will share those new features with the rest of the collaborators, and you do that by combining into these other branches. We'll be looking into that in the practice section. Now, another way in which we organize our projects are tags and nodes. Tags are typically used to denote the versions of our models. And this is the same mechanism that is typically used for versions of mainstream software. So, for example, we create a version 1.1, a version 2.0, and in the future we'll have version 3.0, and etc. When we tag some commits as versions, we are saying that these are stable versions of our model with stable features, and that future versions will have new features that are stable as well. We usually use tags only on the master branch, but you guys are free to use tags everywhere. A similar concept is a node, and a node allows you guys to supplement the description of any commit in a way that you don't have to create the commit again. So one important part of a commit is that it is stable. Let me get back to it just for a moment. Because of this mechanism of hashing, Git has a mechanism of validation of every change that you guys do. And it constitutes a backup of every version of your source code. So this has the downside that you guys are not able to make changes to commits. It is not easy. But you have the mechanism of making notes, for example, to mark commits that have errors, that have problems, and that need corrections. You guys are able to explore tags and nodes using concrete commands from Git that we'll be looking into later. Okay, now what's a Git repository and what does it have to do with your project? This represents your project. So your project is divided into 3 sections once you start using Git with it. The first section is the workspace, which are your current project files, the current files of your model, your simulation, your program. And these files are stored in your laptop for direct use with any editor you use or UI. And when you use GitLab or GitHub, that workspace is also available for you to download directly from those services. There's the Git repository, which is a folder within that project folder. Usually this project, the name is .git. I don't really know the name in Windows, but in Linux and Mac systems it's .git. It's a hidden folder that contains everything related to the history of your project. It contains the commits, the branches, the tags, the nodes, and everything is stored in your laptop, and in the web services are perfect copies of these files. And the Git, being a system that is distributed, will have an exact copy of the repository among all the collaborators of the project. However, you guys will be in control of when this information will be distributed or uploaded or downloaded all the time. So the fact that you guys have Git everything in your laptop will allow you to introduce commits and changes individually without the need of access to the internet. Even if those servers, GitHub or GitLab, crash, you still have everything in your computer, which is a big advantage over previous tools. The final area that you do not have on the web services is the index. We also call it the cache or the staging area. And it allows you, when you use the basic tool Git package, to have an area for which you will select which changes you will commit to the Git repository. Sometimes when you're working, you make notes on your project files, and some files you do not want to be committed into the repository. So you can select which changes will go into your commit by using the staging area, and we'll be looking into that. In order to use the web services, let me give you the other example. I'm using GitLab right now. So I'll go to my projects. I have a bunch of private projects here. So I create a new project. And I call it tutorial. And I put a short description here. This is something that you guys should have done already, okay? And create the project. As I mentioned a minute ago, what I get here are the instructions, the command line instructions to use this web service repository into my own laptop. So what I will do is to clone, git clone here. So I just copy these instructions here on my terminal. And these instructions here, they not only create an empty Git repository, they also link this local repository that I have here in the laptop with the web service. Let's quickly examine those commands. The first command was git clone, and git clone will include the address of the GitLab server, the username, and the name of the repository that was just created. The second part, going into that folder and create an empty README file. The README file is added and committed as the first commit of this repository. After that, this other command is used to move the README file into the repository. We'll be looking into those commands again in just a moment. Now, back to the commands used to create commits. So, the first command we always use is git status. Git status will give us the following information. It informs us of what's the current branch, and the branch is master. As I mentioned, this is the only branch that is existing in our repository right now. The second line, your branch is up to date with origin master. This represents that currently the information that I have in my laptop is synchronized with the repository on GitLab, and that currently I have not made any changes to the source code, and because of that there's nothing to commit, and the working directory is clean. Okay? Now let's make one file. This file will be your source code of your model. I will just print and save this file here, tutorial, as hello.py. So this is a Hello World Python program. Now, when we run git status, we see the new file that has just been created. So you guys please do the same. Create a little file and put it in your working folder. And for those of you who do not have Git, just create a folder in your hard drive and create this small source file. Okay, just one line. This is all we need for now.
Do you ever use source tree or something on desktop or that makes this a lot easier?
You can use it.
Yeah,
Okay. You can use it. You can use it. The good thing is that you can actually use any tool with your working space. Okay. So you can use any GUI. You can use Visual Studio. You can use any design program, any editor, etc. on any of these files. Okay. Okay. Are you guys finished with this small file? So one recommended practice with your source files has been always to save frequently, right? Now the second practice that you guys should exercise when using Git is to always make sure that your code works, because sometimes we make changes and we save and it turns out that the code doesn't even compile or produces errors when executing. So we save it, we make sure that it works reasonably well, and for example in this case of a Python program, I would run python hello.py and it says hello world. That's all it does. Okay, now let's look at what happens in when you use Git on your laptop. The first thing you do is to add this file that is in your working space. Add it from there into the staging area, and the command you use for that is git add. So git add, you can use it in different ways. You can just add hello.py, you specify the file, and then you use Git Status. And now what we have here is the list of changes to be committed, and the file is hello.py. When you're secure, when you are absolutely sure that these are the changes, that your file works well, that your source code works reasonably well, then it's time to commit the change to your repository. So let me get you back here. What we just did was to indicate that this file that was in our workspace should be included into the staging area. So we have moved this file into the staging area, and the file anyways is still available to us.